So, welcome to my YouTube channel. Today we will start with the next type of equation. That equations are known as the Bernoulli's equation. Firstly, we will see what are Bernoulli's equation. Then we will see how you can solve the question of Bernoulli's equation. So, as we know, if we have a linear differential equation, this equation is dy by dx plus py equal to q, where p and q are functions of x. Now, what are Bernoulli's equation? Your Bernoulli's equation is dy by dx plus here is a py. In this case, your q is also multiplied with some values of y or some function of y. So in this case, again, p and q are function of x alone. Then this is called a Bernoulli's equation. Now, if this is a Bernoulli's equation, how we can solve? So firstly, we will convert or reduce Bernoulli's equation to linear differential equation. So to do this, firstly, whenever you will see any type of question, we will try to divide this with whatever the function of y is. So if we will divide it by yn, 1 by yn, dy by dx, py, yn, qyn divided by yn. So here is y minus n dy by dx 1 minus n p q. So our equation is reduced to this. Then what we will do now, whatever the value, whatever the coefficient of p, that should be put into another variable, like I am putting here u. So if I want to find a derivative of this is 1 minus n y 1 minus n minus 1 dy equal to du. Derivative with respect to x of both. So here what we will get, y minus n dy by dx du by dx. So we can see the value of this term here is du by dx. Now it is du by dx plus p. The value of this is converted to u. Now this equation is our linear differential equation. So what is the solution of this equation? As we have done earlier, here is one thing is pending. This term comes over here. It is this one. So it does not affect too much because n is a constant, so this term would be a constant. It can be easily rearranged. So how can you solve now this linear differential equation? By previous method. Firstly, we will find integrating factor, which is integration of, which is a integration of p dx. Then its solution is u into integrating factor, q into integrating factor, dx plus c, and we will again, after solution, we will substitute again the value of u. Now we will see this thing or we will try to solve this thing by taking an example. Suppose our equation is x y dash y y square. As we know, how can we write it down? It can be written dy by dx plus y square. It can be also written as divided by x. See, this is not a linear equation. Why? Because if we will compare this equation with our linear equation, in this case p and q, these are the function of x only. Here p is a function of x only, but in q it can also contain your y. So this is not a linear equation. We have to reduce this equation into a linear equation. So this is the same case as our Bernoulli's equation. So what we will do here, we will convert this equation into linear equation. So firstly, we will divide equation by y square. So it is 1 by y square dy by dx 1 by x y over y square 1 by x y square divided by y square. It is 1 by y square dy by dx 1 by x. It is a y minus 1 and 1 by x. Now what we have done in method, we will substitute this term as in another variable. So if we will put y inverse is equal to u minus 1 y minus 2 dy by dx equal to du by dx, simply y minus 2 dy by dx is minus du by dx, or 1 by y square dy by dx is minus du by dx. So if we will see here, this term is minus du by dx plus this term is our what? This is our u, and the next is 1 by x as it is. We can multiply with minus, so it is du by dx 1 by x into u minus 1 by x. Now this is linear differential equation. We can easily solve this differential equation. Now how we can solve? We will find first integrating factor. It is e p dx, e minus 1 into dx minus 1 into dx minus log x inverse 1 by x. So what is solution? U into integrating factor q into integrating factor plus c. U as it is, integrating factor is 1 by x. Q, what is the value of q? That is minus 1 by x. So we will put here minus 1 by x. Integrating factor is 1 by x plus c. So ux divided by x minus 1 by x square dx plus c. Again u divided by x minus 2 dx plus c. U divided by x. What is the integration of this? It can be minus 2 plus 1 minus 2 plus 1 c. So u divided by x, here it is minus 1 plus c. Further, u divided by x, it should be a 1 by x plus c. Now we will again resubstitute the value of u. What is the value of u? U is y inverse. So here we will put the value of u is y inverse divided by x, 1 by x plus c. So again, y inverse x is multiplied 1 by x plus c, y inverse x into 1 by x, cx, y inverse 1 plus cx. So this is the solution of Bernoulli's equation.